Now we are going to be recording. So we're just going to be reviewing today. Now, before we get into that, we're going to go ahead and I'll pull this so it's its own little tab, because otherwise you guys are going to see the insanity of how many tabs I have open on my computer, and it's a little embarrassing. So, okay. Now what you guys see right here is a extra credit assignment that you guys have at your discretion that you can do whenever you want. So effectively, you're trying to go through ballpark height, weight, VO2 max, all of these things for a superhero. You guys can see a previous example of this when I kind of break down the Doom Slayer from Doom 2016. And I personally have a lot of fun with it. You guys can go ahead and try to do your best with it. Obviously, we got our limits. You guys have seen those before. But here's some other things I added. I put in homework quizzes for chapters 17 and 18, along with 19, and then just the other chapters that we're not going to cover for the class. If you guys choose to or not to take the 19 and then the 13, 20, 21, 22 quizzes, it's not going to hurt your grade. It's just a potential 10 points of extra credit with doing those. 17 and 18, however, are going to be required. And it's just a homework quiz, so you will not have to deal with a chapter quiz over it, though there will be some questions over them, more application on your final exam. So make sure that you guys are doing that at some point in the near future. All of these are going to be open until effectively the last Wednesday in April. So that's my little spiel there. Remember, you guys have got the GymAware velocity load and then power fatigue labs that are coming up this week. I know a couple of you guys have contacted me about when you're going to come by and pick up the GymAware units. And that's all good. Just we're going to make sure that we get those to you. I did shoot a bunch of videos yesterday. I'm going to hopefully shoot another bunch of videos today, so you guys can have another form of, or another videos you can watch of the speed movements, so you get an idea of what it should look like. I just got to do a lot of uploading. So I'm going to be taking care of that a little bit later on. So let's go ahead and let's start reviewing. So the final is about application of knowledge, meaning you're going to take the information that you have and you're going to go ahead and think about moving forward as we go chapter by chapter. So effectively, the first thing that we want to go ahead and think about is, okay, given an athlete in a given endeavor, okay, we're going to kind of break it down once again, chapter by chapter. So chapter 1, what do we really talk about there, guys? What's chapter 1 all about? Yes, muscles, how muscles work, how they're going to go ahead and how fiber types are there, how we get cross bridging, and how we get an action potential, okay? Now, obviously, we're looking to apply the information we get there. So why do we care about electrolyte levels? So sodium, potassium, and then also by kind of the nature of the beast there, what about, shoot, would be another good example there. And then calcium. Why do we care about those? Because remember, we need those electrical chemical gradients in order so we can get our muscles to contract. So bingo, if we don't have enough of one or the other, we might have an issue with cramping, or we might have an issue with just having a hard time with recruiting, along with when we're talking about calcium. Well, remember, that's what we need for in order to get the muscles to contract in the first place. So if you don't have enough calcium, you're going to have a hard time, not to mention, obviously, if you're pulling from your bone mass, now we're talking about increasing risk of breaks, increasing the risk of injuries. Now, what about with the actual fiber type? So let's work our way through a scenario, okay? Go ahead and somebody give us a sport. Rugby it is. Okay, so if we're working with just a normal average person, and our goal is to turn them into a rugby player, okay? How do we think their muscles are going to change as we're training them to play rugby? In what all ways is the muscle going to change? Both of those questions, Colleen and Courtney, it's not so much need, but remember what's going to happen to our muscle fiber types as we train. And the muscles that we're using specifically for the sport. Okay. And so we're increasing the amount of sarcomeres when we're talking about hypertrophy, but what else is going to be changing with those muscles? And that's the size part of hypertrophy, absolutely. But think about muscle fiber type. How is that going to shift? Absolutely, Colleen. Remember, we're going to see a conversion away from 2X, and we're going to see some of those hybrid fibers going from type 1 to 2A, but mostly kind of a convergence on 2A, since that's going to be probably a lot more what we're going to do. So remember, our type 1s are slow twitch fibers. Those are the ones that obviously are really good for long distance activities. Our type 2A are our fast twitch aerobic, and then our type, well, with anaerobic components, and then our type 2 B/X, those are going to be our fastest fibers. So your average person, if we were just to kind of look at them, we would effectively have about 50%, which is going to be type 1, and then 50% that's going to be type 2A, and X amount of these will be the B or the X. That was incredibly bad handwriting. I apologize. Okay. Now, the way it's really going to look with most people is what we're going to have. Sorry, I'm formatting the chat box so I can kind of see what I'm doing as I do it. Is we're going to have, still getting used to the new desk. Sorry, guys. We'll still have about this much that's type 1. We'll probably have about this much that's 2A. And we'll have this much that is X. Okay. But then when we really look at our fiber types based on hybrid fibers, that's going to be the very different situation, where we'll say your average person, this much would be pure type 1. This much would be type 1 slash 2A. This much would probably be, we could go right about there, pure 2A. And then this much here would be 2A slash 2X. Does that make sense to you guys as far as hybrid fibers? No, they're effectively interchangeably. If you want to get into a debate with a bunch of muscle physiologists about nothing, the effective thing is the 2X is the fast twitch that we typically like to refer to it in humans, though. Setup wise, it's much more similar to the B when we're looking at mouse fibers. And actually, big cats and otherwise, they actually have type 1 to They have type 2, A, B, X, and D in rodents. So don't worry about that. But does the hybrid fiber stuff make sense? So as we're going through doing this rugby training, we're going to see, obviously, this line move over and this line move over, so that effectively the lion's share is just going to be that 2A. And this is by no means perfect, guys, and I'm probably overestimating the amount of hybrid fibers, but that's the type of interaction we're going to have. Does that make sense? So if we were talking about something, this would be for the rugby athlete. Using a mouse to type with and being left-handed, I find is not good. Now, meanwhile, we would see this type 1 pushing over, and then this 2A pushing over if we were going to try to be something like a cross-country athlete. Does that make sense? How we're going to have these fiber type transitions and changes? Okay, so how is their neurological system going to change as they happen to be going through this training for rugby? Actually, you know what? We'll divide you guys up. So yes, but we're going to talk about in what ways. Randall, that's a great question. Randall, you were there for the earlier lab section, right? Oh, sorry. Well, oh, perfect, because actually your group members were actually emailing me about it. So give me a second. So I'm going to use names and how each of those systems can be influencing the athlete's performance in the sport of rugby. And remember, we're talking from someone who's pretty much sedentary, not really doing anything, and then how are those systems going to go ahead and change with time? It's 1:44 right now. We'll plan on coming back at about 1:55. So make sure you guys are going in depth as you're going through those questions. Now, when we talk about the neurological side, make sure that you're keeping in mind all of the different, not just the somatic and our parasympathetic nervous system, but then what's going to change with reflexes, what's going to change with neurological coordination, think about rate coding, think about synchronization. Now, when we talk about energy systems, we obviously have our 4 energy systems. How are they going to be changing through training, and which ones are going to be focused on the most in the way the sport is? Use the power of the Google to inform you guys as to how it works. And then with hormones, remember, not just the hormones that are going to acutely increase our performance, but also the hormones that are going to increase our recovery. So it's 1:45. Hop in those groups when you guys are ready. You got your things to work on, and I will see you guys back at 1:55.
When you're using like a rugby player with where the games are kind of long, but you're also doing like short bursts of energy, you'll use more carbs in the beginning and the fat as the game goes on. Your cardiovascular system will change, your heart will get bigger.
Oh no, we're gonna get there. That's no, you guys just have the neurological side, remember?
Oh, okay. Okay. Well, that's all I got then.
Okay, that's fine. Courtney's group. Okay, I mean, anytime they're going at a full sprint, the ATP PCR system is going to be being used. So it's definitely, aerobic glycolysis is the base. But then at certain points, they're going to be tapping more in the ATP PCR. And then when they're going even further than trying to sprint maximally for 5 or 6 seconds, that's going to be that anaerobic glycolytic. So absolutely, we're going to see those systems change. And specifically, when we say when they change, how do they change for Courtney's group? And then group 3, whenever you guys are ready, go ahead and paste in what you guys came up with. With group 1, think about how the sympathetic nervous system would potentially change. Think about how they're going to learn how to process information, react to different stimuli at a faster rate, improve their obviously hand-eye coordination, really ball coordination, tackling, and learn the tactical side of it. And then maybe even we're going to talk to some reflexive properties. Good. I don't think, don't forget, Noah, about growth hormone, testosterone, and thyroid hormone for energy production recovery and overall well-being. And then also don't forget about cortisol, aldosterone for, the stress hormone for making sure we're going to free up enough nutrients so we can go, along with our aldosterone, antidiuretic hormone, and otherwise to maintain our electrolyte levels when we happen to be going out there and getting after it pretty high intensity-wise when we're talking about playing a sport like rugby. So good. Okay, not bad. With those energy systems, remember guys, we're going to be increasing the enzyme number related to them. We're going to be increasing the amount of mitochondria when we're talking about aerobic energy systems. And we're going to be increasing our glycogen stores among other components. So now we're going to have you guys go into groups again. And I apologize if that instruction wasn't that clear. So now group 1, so Colleen and co, this is where I want you guys to talk about the 3 different major parts of the cardiovascular system and how they're going to change thanks to playing rugby. Okay, so think about what's going to be general, what's going to be specific. Group 2, give us those 5 basic principles of training and how we're going to apply that to our rugby athletes. And then group 3, I want you guys to essentially define those different levels of training, some of that spectrum when we're talking about sports performance. And are we certain parts, do we want to undertrain them? Do we want to have that acute overload? Do we want to have that functional and non-functional overreaching? Do we want to overtrain the athlete? But there's going to be a certain point of the year where you probably want to undertrain your athletes a little bit. Certain part where you're going for the acute overload and certain parts where you're going for the functional overreaching, but kind of getting into when we'd want each of those. Does that make sense to you guys? Awesome. So right now it's 2:01. We'll plan on coming back at about 2:10-ish or so. Take your time, really try to think it through. Obviously going to help you guys bridge the gap. And this is a lot of how we're going to be structuring these reviews, where we kind of take it on piece by piece and thinking our way through it. So stay safe out there, guys. And I'll see you guys back in here in about 10 minutes. So the rooms are open again. Hop in when you're ready. So what do you guys come up with? You guys can unmute yourself if you want to talk through that way. Yep, you want to have some type of progression, progressive overload. That's definitely one of the 5 basic principles of training. What were the other 4? Good, yeah, the reversibility, make sure that we're not stopping. Good job with specificity, making sure we're actually ready for the exact requirements of the sport. Good. Well, individuality, just think of it along the lines of, your athlete's going to adapt at their own rate. So, some folks are going to be able to, you're going to be able to push harder because they're going to make more progress. Other folks are not going to be able to push as hard because they're not making the same amount of progress, and we're not trying to bang anybody up and hurt them. So we want to make sure we're progressing them accordingly. Great job. Yeah. So when we're talking about preseason, we're talking about progressive, acute overload is what we're looking for. maybe a little bit of non-functional overreaching or a functional overreaching, and definitely never touching non-functional overreaching, much less overtraining. And then in season, yeah, possibly risk undertraining our athletes. So, speaking specifically to being in the, the strength conditioning side of it, so that way we're not taking away from the sports performance. Great job there, guys.
So for group one, we had the cardiovascular system, and with training, the heart will decrease resting heart rate. Max heart rate will be around the same, but submax heart rate will go down, I think.
The given consistent work output.
Yeah, hypertrophy of the left ventricle
Mhm.
is going to happen for the amount of exercise. Lower overall blood pressure, more capillaries, increase blood flow to the muscles that you work on, and then plasma volume will change for training.
Rock and roll. And also remember, increase capillarization to the muscles they're using a lot of. And specifically the patterns they're doing more aerobic work with in. So it's probably the muscles of the legs more so than anything else. And then guys, remember, aside from individuality, reversibility, specificity, and progression or overload, we've got variability. So we want to make sure that we're giving them slightly different stimuli, so it's not the same thing over and over again. But otherwise, not bad work, guys, not bad work. This is how we're going to try and structure the preparation from here on out, of kind of thinking through like, okay, how are these systems really going to change? So any other questions, comments, concerns before we wrap up for today? For the lab on Friday, we will be meeting over in the Weaver gym again. So I'll just, kind of giving you guys all a heads up and be ready to meet over there. Any other questions, comments, concerns?
If we're coming in to do the lab tomorrow, should
Mhm.
we still go to Moberly or?
Yes, give me a second. I'm going to,